Hello, testing, testing. Bam. Alright, hello, good morning, or afternoon, evening, wherever you are. This is going to be a really short stream because I'm gonna leave for work in like an hour. Okay, we're doing blind 75 again, Leetcode questions with Python, and we are on this one right now. Product of array except self. Okay, given an integer array nums, return an array answer such that answer I is equal to the product of all the elements of nums except nums I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. You must write an algorithm that runs in O of n time and without using the division operator. Okay. Yeah, I read this question before the stream. I was like, I'm so screwed without the division operator. Because I was like, I could totally just take like the product of the entire thing of nums, go through it once from start to end, find the product of everything, and then for every single element, divide the total product by the current element, and that's your answer. But then it says without using division operation, so I was looking at the hints, and I was like, can you pre-compute the prefix and suffix products? And I was like, oh, okay. If it's like 1, 2, 3, 4, what's the answer for 2, you know? The suffix, 3 times 4, and then 1. Velveteen says, hey, Chet. Oh, hey, Velveteen. Hello. How's it going? I was like, okay, what's the product for 1 then? It's 2 times 3 times 4. So I probably don't need to calculate the prefix sum, right? I can calculate it as I go for each element. Yeah. So for each element, well, even before that, I think I need to calculate a suffix like array, starting from the end to the start. And then for every single element, I take the current product, like prefix product, up till before me, and then times it by the suffix excluding me. Yeah, I think that's the plan. Okay, so step 1, we need to make a suffix array from end to the start. Okay. Okay, now the question is how to do this in Python. Is it for I in range? We're going backwards, so length nums, maybe -1, up till 0. Is that how you go backwards? I'm not sure if that's the most convenient way, but that's the way that I'm thinking of. Let's do a sanity check just to make sure this works. Let's print out the current nums I, and then let's return none as a bogus return value for now. Output is... Oh. I'm actually on my computer this time, so I'm tempted to hop on VS Code and try my hand at these, huh? Oh, very cool. Hey, we can do these together. Is this not how you iterate backwards through an array? Hold up. Python, how to iterate backwards in array. For I, E in reversed, this looks really long. For I in reversed A, for item in my list, are these really efficient? Because is this like a whole list operation that reverses it? ChatGPT, help me. Python, how to traverse a list in Python backwards. Reverse my list. You can do list. Really? Okay. You can do... Let me ask what this does. What does this do? Don't think I've seen that operation before, or notation. Slice operation that returns a reversed version of the list. Start and step. Okay. The step is -1, meaning it will step backwards through the list. Default is the beginning of the list. Okay. This is a very concise and efficient way to reverse a list in Python. Is it not possible to, like, just have your index go backwards? It looks like we're doing a whole list manipulation just to traverse our previous list. Is there a way to just have an index go from end to start? Range my list. Why are there so many numbers? That's still indexing as far as I know. Really? What is the efficiency of this notation? Oven. See, it looks like we're doing a whole list operation, like oven. But I suppose it is convenient. This range thing is not very... Start, stop. Stops at index 0. Okay. I'm definitely seeing a lot of this. It kind of irks me that it's oven time. My list. Okay, I think I'll use this one then. How does this work again? Start and step. Okay. Start and step. Okay. This seems to be a common method to do it, so. For num in... Oh wait, I need to know what the current index is too. So maybe the range thing is better for me. Step, -1, -1. Maybe the range thing is better for me, because I need to know the current index so I can store it in the suffix array. So for num in range, we'll start at length. Nums -1. We'll stop at -1. Our step is -1. So range, by default it goes... Well, by default it can only go forward, huh? By 1. Oh, network error. Bam. Okay, we're going backwards now. 4, 3, 2, 1. 3, -3, 0, 1, -1. Okay, very nice. Okay, so we now need to have a suffix array. Suffix array is equal to just an empty list for now. Oh wait. How do I add these to the suffix array? I can't just do suffix I is equal to nums I, can I? Because who knows what the size of this thing is? Or is this not an issue in Python? Let me try this. Or is Python actually that flexible? Index out of range, okay. Python, how to instantiate list with size. List, okay. Okay. None times 100. All right. None times length nums. Okay, I suppose that makes sense. So you have a bunch of nuns with the same length as nums then. Okay, one more sanity check. Let's print out what suffix is. Four, three, two, one. Okay, yeah. We're definitely iterating backwards. Okay, we need to find our current suffix product now. Suffix underscore product is equal to 1 for now. And at every single element, the suffix product is equal to times equals the current nums I. Yeah, okay. And then suffix I is equal to the current suffix product. Let's run this. Okay, we have 4 times 3 is 12, times 2 is 24, 24. Very nice. 3, 0, yeah, okay, we're good. Cool, we have our suffix array now. So now we need to go through nums from start to end and figure out the current cumulative product and then times it by the nums, well, the suffix product that starts next to me. Yeah, okay. So now we can do the for I in range 0 and then len nums. Index from start to end. Whew, okay. We need to compute our prefix product now. Is equal to 1. We also need to have an array for our actual result too. Result is equal to also none times len nums. Man, this kind of instantiating is so weird to me, coming from a Java background. Just a bogus value times a number of times. For I in range 0, len nums. Okay, what to do here? So my current product to the product of all elements. Okay, product except me is equal to the current prefix product times the suffix product that starts next to me, huh? So suffix product I plus 1. I think we need to be careful here though. this could be out of bounds, couldn't it, if we're on the last one? So if I is not equal to nums, what's the last one? Len nums minus 1, then the product except me is equal to this. Else, if I'm not the last one, wait, if I am the last element in the list, then the product is just the prefix product. Yeah. If I is not equal to nums, my brain is getting confused. Else, product except me is equal to just the prefix product. Yeah. Is there a way to get an element from a list, but if the index is out of bounds, you default to a certain value, like 1, for example? Let me see. Python, is it possible to fetch value from list, but if index is out of bounds, default to a default value? Try except all. There's no really convenient way to do this. To avoid index out of bounds error by clamping the index. Default value is -1. My list is min index. Length my list -1. Oh, I see. I don't really want to do a default value like that though. Okay, I guess this is fine then. Prod except me. Okay, so if I'm not the last number, then I do the prefix times the suffix. Else, if I'm the last one, the last number, the product except me is equal to the prefix prod. Yeah, okay. And then after every iteration, the prefix product is updated, times equals the current number. Nums. Okay. I have a feeling okay. Do I need to put prod except me outside of here so that I can access it later? Python, how to instantiate variable with nothing assigned to it. Must be assigned a value when they're instantiated, okay. Is equal to none then? Okay. Let's print out what our current product set mean is then. Sanity check time print prod except me. I have a feeling something is going to go wrong, but here we go. Okay, runtime error. Int object has no attribute get item. int object. Is it talking about the suffix product? Oh, shoot. Suffix. Velveteen says, ah, dang, I didn't see the O of n part. My solution is O of 1. Wait, that's even better, though. Oh no, I did better than the suggestion. Wait, how did you do it O of 1 time? List out of range. List out of range. Why is this out of range? If I is not equal... Huh. What is the length of suffix? I should probably look up what those actually are. I never heard of that before Leetcode. Like the runtime notation? Wait, I don't get it. How is this out of range? Maybe I can try printing out what the current index is. Print current I and then I. I can also print out what the current suffix length is. Print suffix length is equal to length of suffix. Yeah, see, it doesn't really make sense why this is out of bounds. I feel like I've bounded it pretty well. Oh, here. Suffix length is 4. 1, 2, 3, 4, yeah. Oh. Wait. Oh, I see. I'm dumb, so indices start at 0, right? So the second to last element would be -2, wouldn't it? What? Wait. So current is 3. That means we're trying to look up what index 4 is. If I is not equal to length nums minus 2, 4. Wait, this should work. I'm confused. 3 suffix length. Silver says, oh, the Leetcode streams are back. Yep, this time's in Python, so the struggle is real. Current I is 3. If 3 is not equal to... This should be 3, right? Oh, wait. What am I doing here? Why am I fetching a value? This should just be a length nums minus 1. Cool. Okay, we're getting somewhere now. I think... Okay, let me remove all these print statements now. 12... Okay, 24, 12, 8, 6. 24, 12, 8, 6. Okay, we're on the right track. 00900, 0900. Okay. I think we're getting there. So now all we need to do is update our results with the product except me. So result I is equal to product except underscore me. And then you return result at the end. Nice. Submit. Hey, nice. We got it. Velveteen says, oh, I misunderstood the question completely. I did the sum of the array without I in it. Oh, that makes sense. Okay, I feel like I did this in a really, like, non-Python way. Let's see what these solutions are. That looks really complicated. They imported NumPy. Okay, here's someone of my caliber. What about this one? Okay, let's try to understand this one maybe. This one looks more readable. So n is equal to length of nums, okay. Answer is equal to 1 times n. Okay, that makes sense. Oh, I didn't know you can do this. L is equal to r equals 1. Huh, you can instantiate variables like this, huh? Multiple equal signs. For I in range n, huh. Answer I times equals L. I guess this is the sum from the left. L is equal to nums I. Okay. Okay, so he's taking the prefix sum here. For I in range n minus 1, minus 1, minus 1. Oh, he's doing the range thing like me. Answer I times equals R. R is equal to times equal nums I. Oh. Return answer. Okay. I see what he's doing. Solar send me something. Hey, nice Solaris. Ooh, let's see what you're doing here. Suffix is equal to num. Wait, this looks strangely like what I did. Oh, never mind, he didn't. The code is in the bottom left. Oh, okay. It's like, this looks strangely like what I... Wait, this looks so efficient. Product except self. X is equal to 1. A is equal to... Holy, what is this? So, is the 0th index 1 plus x times e for e in nums. Wait, what is this? For e in nums. So every element nums x times e. What is this? The prefix product? Huh. This notation makes no sense to me. I've never seen this before. Dang. This looks like a very clever thing. Let's ask ChatGPT to explain. Explain this Python code. Solar says both does the affectation and the calculation. This is a list with a single element, 1. It's the first element in the new list, A. This is a list comprehension which will iterate over each element E. It performs the operation inside the collection, the comprehension, and collects the results in a new list. Oh, it's the walrus operator. Okay, which allows you to both assign a value to a variable and use it in the same expression. So it assigns the value x times e to x and also returns the value of x after the assignment. In each iteration, x is updated. Okay, got it. Okay. What's the initial value of x? Just 1, I guess? X is equal to 1. Oh, here. X is equal to 1. Okay. Okay, so you take the prefix sum here, you set x to 1. For e and nums, I imagine you're going backwards here. This notation, man, it's so confusing to me, but I imagine you're going backwards. Return a I times bi for I in range lane nums. Dang. The code looks pretty clever. Why is it like not that efficient though? Is it because you're reversing the list? Why? Well, how can the runtime of this code be improved? The code performs 2 full passes of the list. So 3. Okay, constructing A is sure. You take 3 passes, I guess. All right. Krishna says hi. Hello. But yeah, it's still O(n) time, so it's fine, I guess. Where did the solutions I was looking at go? Krishna says so early. Yeah, so early. This is gonna be a really short stream because I have to leave at like 8 in like 15 minutes, I guess, because I have to hop to work. Okay, this looks so elegant. I like this. I want to see if I can replicate this too. N is equal to length nums. Answer is equal to 1 times n. Man, this really is so elegant. Do you think I can cover this and recreate this? Probably. Yeah, and he doesn't have to worry about like this case. It's really elegant. So basically he computes the prefix sum and then he chooses, you know, the corresponding index to add it to. Okay, I only have 15 minutes left. It's probably not enough time to do another problem, but I think I'll try to do this the more elegant Python way. Okay. So, how do we do this? Let's first calculate. Did he instantiate answer? Okay, he did. So the answer, let's call it the result, is equal to just 1 times the length of nums. Okay, let's calculate our prefixes first. Prefix is equal to 1. So for I in range I in range from 0 to the length nums so the answer or the result at I is equal to the current prefix. And then we update the prefix because we don't want to multiply the current number. Times equals nums I. Yeah, and then we'll go backwards now. We'll find the suffixes. For I in range, lane nums, and we'll stop at -1. We can't just put 0 apparently, it's -1 because it's non-inclusive. And then the step is -1. And then at each result, we'll multiply it by the suffix. So suffix I, well, result I, can we do a times equals? Times equals the current suffix, which we need to instantiate still. So suffix is equal to 1. And suffix, and then we'll update it. Suffix times equals the current I. Abby says, hi. Hello, Abby. How you doing? Suffix times equals what the current thing is. So nums I. And in the end, you return result. I think that's how they do it. I'm not sure if this is going to work right off the bat, but we can debug it if it doesn't. Runtime error. Okay. Index out of range. Oh, we need to start 1 minus the index. So, yeah, lane nums is out of bounds by 1. Last index is actually -1. Okay. Runtime error. Times equals, oh, it's nums plural, not num. Hey, let's go. It worked. 78th percentile, let's go. Yeah, I think I like this solution a lot more. Yeah, we actually don't need to store another list. This is all, or like we did not need to store a suffix array. Velveteen says, ooh, I never noticed your hair sparkled. Yeah, my hair sparkles. Yeah, it's like kind of glittery, I guess. Okay. Yeah, I like this solution a lot more. I think it's way more readable than our first solution. And it's a lot simpler too. And we do not need to store a whole nother array for our suffix. Yeah, I have to leave in like like 10 minutes, but I think there's some things worthy of noting here because I learned some new stuff. So I guess this is how you instantiate a array of certain size. You just take 1, like you make an array of 1, like an array literal of 1 length of whatever type you want, like this, and then you multiply by the length of the array you want. So, okay, let me write it down. List, I guess list instantiation. Times length. Okay. And what else did I learn today? This weird thing. Apparently in Python, range goes up 1 by default. You need to specify a -1 step for it to go backwards. So maybe I should just write down what range does. So range, it takes in a start, end, and then a step. Cool. Yeah, I think that's the most important takeaways for this problem. So array instantiation like this, range going backwards like this. Okay, we definitely do not have time for another problem, but maybe we can look at another problem, but just not do it. Maximum subarray. This sounds like a recursion problem. Maybe we can do this next time. Given an integer array nums, find the subarray with the largest sum and return its sum. What is a subarray in this case? A subarray is a contiguous non-empty sequence of elements within an array. Ooh, the subarray with the largest sum. The subarray 4, -1, 2, 1 is the largest sum x. I mean 6. Yeah, I already don't really know how to do this, even without Python. Is this sliding window? Largest sum. I mean, brute force would be like literally for every single element, try all the other elements as the end of the list. Man, I feel like I should really know how to do this. I've literally saw this before. This is not recursion, is it? 1, 5, 4, -1, 7, 8, 23. Is this sliding window? Divide and conquer dynamic programming. Oh. Divide and conquer. I'm actually so curious. Yeah, I don't know how to do this right off the bat. Divide and conquer dynamic programming. Wait, prefix sums. Is this not prefix sums? So if we find all the prefix sums of this. Oh, I think I know what to do. I can write some pseudocode. So we can find the prefix sums of everything, right? We can do one pass, find the prefix sums, because for continuous subarrays, for example, the sum of this would be equal to the prefix sum up to 1 minus the prefix sum up to -2. So for every single element, we can see like okay, my current prefix sum is this. What's the minimum prefix sum to my left that I can subtract from myself? Oh. Maybe we can track the current prefix sum, go from start to end, track the current prefix sum on each element, and then keep a priority queue of the least prefix sum to my left, and then keep taking the difference between my current prefix sum and the min prefix sum to my left, and then track what the largest one is. Maybe that's the solution. Okay. start with the idea if we want to find the maximum sum of any element, use a single loop to traverse the array, keep track of the current sum and the maximum sum. If the current sum becomes negative, reset it to 0 because a negative sum won't help in maximizing the result. Huh. Dang, it's much simpler than I thought. So n is equal to length of nums, max is num0. For I in range, if sum is less than 0, then you reset it completely. Oh, I guess that makes sense. Yeah, why continue when your previous thing is negative, huh? Okay. Dang, that was simpler than I thought. Alright. Well, I over-engineered my solution. Okay. Well, I think I need to go about now. Yeah, I need to leave at work at like in 5 minutes. Thank you everyone for coming then. Yeah, hopefully there will be more Python Leetcoding streams. See ya. Thanks everyone. Thank you for tolerating shorter stream. Bye.